Today we're going to talk about completing the square, and there's one step that we did in our previous notes that was listed in our previous notes that we haven't used yet. And that's going to be step 2 in here, which is going to be divide all the terms of the equation by the coefficient of x squared if it isn't 1. So I want to go back to the box up here at the top, and it says in order to use completing the square, the leading coefficient, which is the number in front of the x squared, has to be 1. It has to be. But if it isn't 1, we need to make it so that it is 1. And all that we have to do is we have to divide. We have to divide everything by that leading coefficient and complete the square as usual. So our steps aren't going to change. I will say that I tend to do step number 2 first. I tend to divide all the terms of the equation by the coefficient of x squared first, and then put the variables on one side and the constants on the other. It does not make any real difference when you're doing these problems. So if you tend to put the variables on one side and the constants on the other at the start, that's good too. For most of you, if you understood our previous notes for completing the square, these are going to be very quick for you to understand. And as we look at this problem number 1, our first example, 6x squared plus 12x minus 48, we cannot complete the square when the equation is written like this. So what I'm going to do is I'm going to divide every term in here by 6, including the 0. But 0 divided by 6 is still 0. So we end up with x squared plus 2x minus 8 equals 0. The number in front of the x squared term is positive. But positive 1, which is what we want. And now we can complete the square, and all of the steps that we did in our previous notes are the same. Now, put the variables on one side, constant on the other. So we're going to add the 8 to both sides. When we do, we get x squared plus 2x plus something equals 8 plus something. The nice thing too is, for those of you who were absent yesterday, I hope that I can get you to understand the concept. To figure out what goes in this blank space, we're following the same thing that we did yesterday. We're going to take b, which is 2, divided by 2. It's always divide by 2, and square it. Well, 2 divided by 2 is 1, and 1 squared is 1. And if we add 1 to the left side of the equation, we need to add 1 to the right. The thing is, when we get to our next step, which is going to be to factor the trinomial, if we take the time to write down that step that I have in blue, then the factoring can be simple. Because we're creating the perfect square trinomial. That means we want the same values in each of those parentheses. And we know that x squared is x times x. Well, when we look to the far right on our screen, we see that 1 squared. This is going to be plus 1. And it's the 1 inside the parentheses is what I'm getting at. I know 1 squared is 1. But it's the 1, the value of 1 in the parentheses that we're using for our factoring. Otherwise, we have to split the middle. It just makes it more steps. I'm trying to cut down on the steps. When we look off here to the right, we can add. 8 plus 1 is 9. So now that we've factored, let's condense it down. And we get x plus 1 squared equals 9. So we factor. That's going to leave us here at step 5. Take the square root of both sides. Taking the square root here, and taking the square root here. Square rooting and squaring are inverse operations. we get x plus 1. On the right side, can we take the square root of 9? And it's 3. Don't forget that it's not just 3, it's plus or minus 3. Positive 3 times positive 3 is 9. Negative 3 times negative 3 is still 9. So the nice part on this particular problem is that we don't have a radical in our answer, and if you look at the bottom of your paper, we've got the stars down here. And I know that I haven't completely solved this quadratic, but because we did not get any square roots or i's in our answer, our solution is going to be 2 real rational numbers. We're going to be able to compute what are the actual 2 answers to this problem. So we can subtract 1 from both sides, and we get x equals negative 1 plus or minus 3. But what that also means is, as I scoot this down a little bit, hopefully you have enough space. This means when we calculate out that value, that x equals negative 1 plus 3, but x also equals negative 1 minus 3. Negative 1 plus 3 is 2. And negative 1 minus 3 is negative 4. 2 real rational answers. Could we have used any of our other methods? In fact, one of our favorite things to ask you is this quadratic factorable? Could we have factored? Is there any other way? Yep, we could have factored. Well, after we factored, we did solve by graphing. Could we solve this quadratic by graphing? Most definitely. And our third method that we explored was solving by quadratic formula. Can we solve this by quadratic formula? This is, and let me write it correctly, this is a nice quadratic because we can use any of our methods on this particular problem. Factoring, quadratic formula, graphing, and our new method, completing the square, as well. But as we turn our paper over, what I want to primarily stress today is that when we use the complete the square method, we cannot have a number in front of the x squared term. So in this particular case, we have a 2 in front of the x squared term. Let's not have a 2 in front of the x squared term. So let's divide everything by 2. That's step 2 in our list, which I tend to do first. I'll try to do the next one by going exactly in order. But we get x squared plus 16x minus 7 equals 0. And now that we rewrote the equation so that there's no number in front of the x squared, we can solve this problem. And we're going to solve by completing the square. Our first step then is to rewrite this so that the variables are on one side and the constants are on the other. We're going to add 7 to both sides. When we do, we get x squared plus 16x plus something equals 7 plus something. See if you can figure out what goes in that blank before I do. I'll pause and I'll let you try. See if you can figure out what goes in that blank. Did you get 64? Here's where I got 64. I hope it's the same place where you got 64. We take 16, divide by 2, which is 8, and square. 64 is a little bit bigger number than we worked with before, but that's okay. It's b divided by 2, and then we square that number. And that leads us to our next step here, which is going to be the factoring. And if we look back at our blue step there, it's going to be x plus 8, x plus 8. Here's where the 8, that blue 8 off to the right of our screen, is where we got that value. Otherwise, we have to split the middle. That's going to take more time and energy. Over here on the right side, 7 plus 64, 71. And let's condense it down. We get x plus 8 squared equals 71. And that leads us to our next step, which is to find the square root. And the nice thing is that square rooting and squaring are inverse operations. They cancel each other out. So off to the left, we're simply left with x plus 8. Over here on the right, don't forget that when we take the square root, it's going to be plus or minus. We had to do that under our previous example. And now we can finish with our last step, which is to solve for x. Subtract 8 from both sides. And we end up with x equals negative 8 plus or minus square root of 71. If you were here for the previous notes, this is probably making complete and total sense to you. And if you weren't here for the previous notes, then hopefully it's starting to come together for you. But let's take a look at our last example here. And I do hope to get in the quadratic formula on this one as well. I believe that's part of this problem. But if you infringe on the space there in the quadratic formula, my main objective here is to get us to understand completing the square. And then we can kind of review the quadratic formula again. But if I follow the steps exactly on here, the first step says rewrite the equation so that we have the variables on one side and the constants on the other. So in this particular case, what needs to happen is we need to add the 64 to both sides. We have negative 4x squared plus 32x. Whoops, and this one isn't the one with the quadratic formula. Equals, what is it? 96.
Okay, so why are we subtracting or adding that 64?
We are going to start this example over, and I'll stick with my original method here. And my original method is we have a number in front of the x squared term. So let's divide everything by the number in front of the x squared term. My other method would work just fine, but so will this. So I'll stick with my same method here. When we divide everything by a negative, watch out because we are dividing by a negative, but we get x squared minus 8x plus 16 equals negative 8. And now I'll go back to step 1. And step 1 says put the variables on one side, the constants on the other. So subtract 16 from both sides, and we get x squared minus 8x plus something equals negative 24 plus something. Let's figure out what goes in that blank. By the way, if you want to write it as a box, write it as a box. But what's going to go in that blank is -8 divided by 2 is -4 and squared. And -4 squared means -4 times -4, which is positive 16. Which leads us to our next step, which is the factoring step. And if we take the time to write that blue step, when we factor, this is going to be x minus 4 times x minus 4. It's the entire value in that parentheses. So not only did I take the 4, but I also took the negative or the minus, however you want to look at it. On the right side of the equation, we can add -24 plus 16, which is -8. Once we factor, we can condense it down. And this is x minus 4 squared equals -8. Our ultimate goal was to solve for x as it is when we solve by factoring, or we solve by graphing, or we solve by quadratic formula. So now we're to the step where we have to do the inverse operation of squaring, which is square rooting. Take the square root, step number 5 in the list. And square rooting and squaring cancel each other out. And we're left with x minus 4 equals plus or minus the square root of 8. But we need to be careful here. And I need to be careful as well and make sure that we're taking the square root of -8. But we need to simplify this. So the square root of -8 means that we're going to be taking the square root of -1, and we're going to be taking the square root of 8. What does the square root of -1 equal? It equals I. The more you say it out loud, the more you'll remember it. So we get x minus 4 equals plus or minus something I. But not only do we have to simplify that, we need to simplify the 8. And 8 is 4 times 2. And 4 is 2 times 2. If you prefer it written like this, 2 times 2 times 2, we need 2 of the same value to take out 1. 2 of the same value to take out 1, which means that we can put a 2 over here in front of our I. We have a single 2 underneath our square root. That's going to stay there. Now that we've simplified the square root of -8, that leaves us with our last step, which is to solve for x. And it's going to add 4 to both sides. We'll get x equals 4 plus or minus 2I radical 2. So I was a little bit ahead of myself, and I may run out of time in terms of the quadratic formula, but I do want to finish up with example 4, at least the completing the square point part. Last one, again, I may or may not get to the quadratic formula, but I do want to follow the steps exactly on this one, because our first step would be in the steps is to put the variables on one side, the constant on the other. So we get 4x squared plus 8x equals 1. Variables on one side, constants on the other. But the problem is, there's still a number in front of the x squared term. So we need to divide everything by 4. And don't get too far ahead of me, because I am going to put the blank in on this one. We end up with x squared plus 2x plus something equals the 1/4 plus something. If the fractions make you nervous, just use your calculator, because all the rest of the steps are the same. We need to figure out what goes in that blank. So we're going to take 2 divided by 2. It's always divided by 2, by the way, equals 1, and square it. Well, 1 squared is 1, and if we add 1 to the left side of the equation, we need to add 1 to the right side of the equation. And now we're going to factor. Again, if you take the time to write that blue step down, then it shouldn't take you much time to factor. It's whatever's in that blue parentheses. In this case, it's positive 1 again. Over here on the right, do not write your answer as a decimal. It will mess you up in the end. 1/4 plus 1, when you type it in your calculator, 1/4 plus 1 is 5/4. Use your fraction button if you have it. We can condense this down, and we get x plus 1, quantity squared, equals 5/4. And I know we have a fraction in here, but it's still the same steps. We've condensed it down, we factored, we condensed it down, which leads us to our next step, which is to take the square root but this problem is good because it's going to give me a chance to review here. I need to speed it up a little bit. But we get x plus 1 equals plus or minus the square root of 5/4. When we see the square root of 5/4, when we see the square root of a fraction, you can rewrite that square root as x plus 1 equals plus or minus the square root of 5 over the square root of 4. When we simplify, or we break apart 5, the only thing we can do is 1 times 5. Can we simplify the square root of 5 anymore? No. Can we simplify the square root of 4? Yes. If you write it as a decimal, you don't know where the perfect square is in the problem. So this is plus or minus the square root of 5. The square root of 4 is 2. And to finish, to solve for x, we're going to subtract 1 from both sides. Your x equals -1 plus or minus the square root of 5 over 2.